time saver, because we'll be discussing throughout the test the discipline of time management. This is a timed test, and so you need to be practiced and prepared to take this test under timed circumstances. Now, if you're reasonably well prepared, as you will be if you go through this lecture course and do a fair amount of homework at home, you'll be well prepared enough that running out of time should never be a factor. But part of that is sort of you being proactive and monitoring how you're doing on time and adjusting your approach accordingly. And one way that the question is very nice at saving you time, again, half of the math questions will be in data sufficiency format, and these 5 statements, 5 answer choices, are always exactly the same every single time a data sufficiency question pops up. And so it certainly is worth getting very familiar with these throughout the course of your homework, your practice. But by the time the test comes, you should have these internalized. I don't even really like using the word memorized. I just like learned or internalized, that these are the same every single time. So when you come to the question, you don't need to read these answers, because I guarantee you every single time they're exactly the same. And if you follow my courses, you'll notice I make very, very, very few guarantees. But this is one of them. They'll be the same every time. And so if you learn those, I tested it once kind of unscientifically, and it will save you about 2 minutes and 45 seconds over the course of the data sufficiency section if you have these internalized and you don't need to read them each time, which at first may not sound like a lot, but once you get a good handle on how time is broken up on this test, it really is quite a bit of time. That's time for you to answer probably at least 3 questions fully. And the last thing I want to see you do is leave any questions blank. If you do need a mnemonic device to remember these by, there's one. If you'd like to jot this down, at least while you're getting started, PEMDAS, no, I'm sorry, that's for a different area of algebra. It's 1, 2, TEN. So 1, 2, 10. 1, 2, TEN. And those 5 numbers and letters remind you 1 is A. Statement alone would be sufficient. The second one, statement 2, would be sufficient. On the third, T, both of them together would be sufficient. For the fourth one, each statement on its own is sufficient. And then N, neither, is sufficient to solving the problem. And so when you solve these, the method that you want to use is, at first glance, whichever statement appears to be simpler to you, just at first glance, focus on that statement exclusively. And if you need to hold up a piece of paper or hold up a finger or something to the screen and just try not even to notice what statement 2 says. I have the benefit here that I can cover it up, actually. But for your sake, I really do recommend actually covering it up with a piece of paper. I had one student recently, he's just an absolute whiz at math, but he would consistently get these questions wrong because he would let statements 1 and 2 cross-contaminate each other. And what we finally had to come up with in his case was the instant it pops up the screen, just cover up the second statement with a piece of paper so that he doesn't even have a chance to see it, because you want to solve these in isolation. And then it's a decision tree from there. If you look at, for instance, statement 1, again, would be sufficient to answer the question because you don't have to solve it. You just have to know that it would be enough to get you to the solution. Okay. Then you know, and I'm really big on saying not just process of elimination, I want you to attack the answers. So it's a two-pronged approach. First of all, you approach the problem from the front side. Okay, what is the value of? And then B, attack answer choices and whittle them away until you're almost always going to be left with 2 plausible or likely answer choices. And that narrows things down quite a bit. Obviously, better 50-50 chance than 20% chance of having the right answer. So if 1 by itself would be sufficient, then you know that it cannot be 2. You know that it cannot be 3 because you've already established that 1 all on its lonesome would be sufficient. It could be A that says 1 and 1 only is sufficient. It could be D that each of them is sufficient. Now we have to see if 2 is also sufficient all by itself. And we've ruled out E, that they're not sufficient. So if you evaluate 1 statement, then you've already narrowed it down to, in this case, 1 out of 2 answers. And if for whatever reason you get to a section, and this really goes to time management, you get to a point in a problem where you just can't see how to proceed any further, and the clock's ticking, and you're down to 2 likely answers, which is what is probably going to happen. If at that point you feel that you really need to just pick your answer and move on because time's a wasting, you're in a pretty good position to select whichever answer choice you think is the correct one. Because you notice that's not guessing. Guessing, I have a big problem with that. That would just be eeny, meeny, miny, mo. In this case, you've already done the bulk of the work. You, believe it or not, you were solving the problem by eliminating wrong answers. And so what you've done is you've done over half the work. And if you have to choose between 1 or 2, statistically in the long run, you're going to give yourself half credit. I mean, on one statement, you will get it wrong, you'll get 0. On another, you'll most likely get it right, and you'll get full credit. So solving it down to 1 of 2 potential answers, if you're forced to leave it there, that's still worth half credit. So that's definitely a benefit. And so what is the value of x squared minus y squared? What you want to look for in most, if not all, data sufficiencies, this is king. This is something you should really write down and highlight if you have it. 2 things to look out for right away in data sufficiency. You're usually given 2 variables. Is what is the relationship between the 2 variables? And do I have a concrete number to attach to one of these values somewhere? And so in some questions, for instance, you'll be able to determine the relationship between the variables x equals 2y. Okay, y equals 1/2 x. Okay, those two can chase each other around all day, but they can never escape into the wild because you don't have a concrete number to attach to it. So that statement is partially solved, but not entirely solved. Now, if you determine that x equals 2y, okay, you're half the way there because you've determined the relationship between the variables. And then the other statement, for instance, gives you something like y equals 2. Okay, now you've got both pieces of the puzzle you need. You've got the relationship between the variables. You determine that, solve that out or whatever, and you've got a number. Once you come up with an equation, now this is where I do stick with the old tried and true. Whenever possible, I set things in terms of x. So x on the left-hand side, x is equal to, and then everything else. If I can get it to that point, I do not need to solve it any further. So that would, even though, you know, every math teacher from our past in our brain would be saying, follow it, follow through. You don't have to. If you get to that point where you could solve it, that's as far as you need to go. You would take additional time if you solved it. You might be more comfortable moving on to your next question, but it's not required. And so I recommend practicing sort of being content with just enough information and no more.